Hello, everyone, and it's really good to see you back again in this particular session. And we are going to start one series from today, and this series is going to be on Linux fundamentals. So, all those who are aspiring to learn Linux, all those who are studying into CSIT branches, and all those who are working and would like to understand that how Linux platform works. So this is for them. Even those who are into non-IT domain but still need to work on MIS or still need to work on some application support. So this is going to help them as well. And this is the first session, so this is going to be very simple, very conceptual, and beginner level. The whole of this series, the whole of this course is also going to be the fundamentals course. So someone who is having absolutely no knowledge about Linux can come up, can try to join this particular session and will be able to understand more on how basically Linux platform actually works. And I will try to make it as simple as possible. I would also like to get your questions, your queries, so that I can handle them on live as well. So let me share my screen and let us start. Now, what exactly is Linux? We should start from there. So, along with it, let me open up the Paint window. And before we go ahead, let me just take a little check on how the audio visuals are going on from my team. So that's another thing I should do, and then we will begin. Meanwhile, what you can do is you can check on what exactly is operating system. You can think upon it and help me with your understanding that what exactly is operating system. So from there we will start. So I think the audio visuals are going good. And now let us move ahead and try to understand on the first part, which is operating system. Or in simple, we call it as OS, operating system, PRATNG, operating system. Now, if you see that whenever we buy a laptop or a PC desktop, so at that point, the kind of components which we have, they are one is CPU, then we take up a desktop, and let's say, okay, don't go for my drawings. So let's say this is a desktop, and then some other components like we will buy a keyboard and we will have a mouse. Okay, so a mouse we'll buy. So these are the kind of things we normally buy whenever we have a laptop or desktop purchased. So this is what we actually do. Okay, now what is the importance of each of them? Now if you see that the kind of tool this monitor is, so monitor basically gives the output. So whatever is there running as a software, whatever is there running as a maybe program, as a user, we will be able to see all that in this particular monitor in the form of text, in the form of image. So different formats could be there. In those formats, we'll be able to see the output. What is the purpose of this mouse? It basically gives input. If you understand that you click something, as of now, also I'm not using a touchpad, rather I'm just using a mouse for time being. So with the help of mouse, I'm able to give my inputs, and those inputs here are able to show us again on the monitor that what kind of input instructions did I give, and that gets reflected on the monitor. But but who basically is responsible, or who is behind these particular actions? So we'll come to the answer of this as well. Now we have this keyboard. If you see, this keyboard is also there. From keyboard also we type, and when we type, that is also an input only. So ultimately, if you see whatever we are doing by monitor, that basically gives us the output, and then whatever we do with the help of the yeah, so whatever we do with the help of the keyboard and mouse, that is the input. So monitor gives the output, and keyboard and the mouse, it gives the input to the system. But who is responsible to process all this? Like there is somebody who is responsible to process all this information or the inputs. So that's the most important part, and let me highlight it with the help of blue color. So the most important part is this one. This is CPU. Okay, this is called as CPU. Now, this CPU takes the instructions and then revert back with the response. For this, the CPU also requires some help or something which can help in doing this particular task. So let us now try to understand like what all things come under CPU. So the CPU is a hardware where you have your hard disk. So hard disk could be there, SSDs could be there. So let's say these two blocks, they represent hard disk and SSDs. And then there is RAM. Okay, random access memory. There is ROM, which is read-only memory. And then there are processors, let's say one processor, two processors. So they can be multiple processors. So if there are eight processors, we call it as eight cores are there. So here we have a number of processors. Fine. Let me draw the last one. Now, if you see that this CPU is having so many things, let me write them also. So CPU cores. So that is basically the number of processors what a CPU is having, CPU cores. Then we have RAM, RAM. Then we have ROM. So this is ROM which we have, ROM. And then we have hard disk. And along with hard disk, then we have the SSDs as well. So all of these are there in the CPU. Now, how this hardware can be utilized? Is it like the CPU cores themselves will start processing something? Because the purpose of the CPU cores is that they process some data, some information. But will they start doing it themselves? But how? How is the user interaction possible? Is there a possibility of user interaction? So these are the questions. The RAM. RAM basically helps in very fast processing of the information, fastest component in a computer we call as RAM. So will it be able to do work independently without needing help of any kind of software? And similar is the case of hard disk. And now the answer to all this question is no, we require something. And now we require some software utility which can interact with the hardware, and we call it as firmware. That something is called as firmware, which enable us to interact with the hard disk, which enable us to interact with the RAM, interact with the CPU cores. So that software is called as firmware. It is firmware's task to basically help us interact with the hardware. Now, firmware is quite basic and it helps us to achieve some fundamental functionalities. But when it comes to real time, the firmware also needs some more support, which is of higher level, which is able to manage a lot of things which firmware cannot do. So then OS is required. Okay, that was the purpose why OS needs to be there. So now on top of firmware, we have operating system. So operating system, yeah, so OS or operating system lies here. Okay, so at the bottom, the first is hardware, After that, we have firmware. And after that, we have OS, that is operating system. Now, this operating system's work is to make it so user friendly that users can interact with the operating system and user can make the whole of the hardware infra as a backend. So user doesn't directly go and see the hardware part because the abstraction is given by the operating system. It is all abstract. Operating system gives some basic UIs to see, understand the properties which are configured. It opens up some options of editing and updating the properties, modifying them. So it opens up that provision as well. So that is what is an operating system. And then whatever user applications are there, all of them can be installed, but with the help of operating system. And that became a very interesting and note making change. It basically happened. And then it started to basically get specialization into different types of operating systems. Can you think and name of some of the operating systems you have been using? If you can just think and name some of the operating system, that'll be really great. What you can do is you can write that in the chat. Now, the next thing is we are talking about Linux. So what is Linux? It is also an operating system. Then there is some other operating systems like Unix. Then we have Windows. So there are different types of operating systems which we have, and we will be putting more focus on Linux as that is what is planned in this particular session. So let us come back to the document and try to understand what exactly is Linux. So Linux is a free and open source operating system kernel first released by Linus Torvalds in 1991. It is based on Unix operating system and is used to power a wide range of devices from servers and desktops to smartphones and embedded systems. So if you see that, there are two names which are being used here. One is Linux and the second one is Unix. Linux is open source. What is the meaning of open source? Open source means that we can use it free of cost and there is no requirement of paying any kind of licensing fees. And on the other hand, we have the other system which is called as Unix. Unix is not open source. Unix is proprietary. And if you want to take Unix, you need to pay for it. That means the license cost is involved in case of Unix. Now, we can make use of Unix and Linux in servers, desktops, smartphones, and embedded systems as well. So this is an advantage of using Linux. However, we cannot say that we should not use Windows or any other operating system, but Linux is something which is favorite of many, like many cohorts, many people you will see they like Linux. Okay. The reason for liking Linux is its stability. It is very stable. Security, flexibility, the performance it gives, and along with it, it has got community driven development. So the whole tech community who have interest into Linux, they contribute in the development of further updates in the existing Linux system. Okay, now let us go to a bit of history. So it is very old. Like if you see the predecessor is Unix only, it started in 1969, long back, and it was developed at Bell Labs by Ken Thompson, Dennis Ritchie, and others. Unix was powerful and proprietary and expensive as well. Then after 1963, you can see GNU project 1983. So It was started by Richard Stallman. The aim was build a free Unix-like OS and name it as GNU. So this was the attempt to make a free operating system in 1983. Many components like compiler, shell, libraries were created, but the kernel, if you see, the kernel was missing. Okay, now GNU stands for not Unix, but it's a recursive acronym. It is Free Software Operating System project initiated by Richard Stallman in 1983 under Free Software Foundations. Now, why was GNU created? What was the purpose for it? So it was created to develop or design a free Unix-like operating system where users have freedom to run the software, study how it works, change it to suit the needs, and share with others. That was the reason why GNU actually was developed. And it has multiple components. You can see GCC. I think those who are studying into some IT branch, they must have experienced some Linux and we install certain things into it. And they must have came across this word GCC, this terminology. Now, GCC stands for GNU compiled compiler collection, that is C, C++. So whatever compilers are there. Then Bash. Bash is GNU born again shell. Again, this is a default shell. Then glibc, it is GNU C library for essential system apps. So you can see that core utils, make, GDB are the basic tools which basically will help us to remove something, to create some links, and then after that, if you see that how GNU and Linux are related, so they are not same, but most of the Linux distributions use GNU tools with Linux kernel. So GNU is facilitating here to Linux on multiple, I'll say, utilities. So that is how basically GNU is there. Now coming to the 1991 journey, and into this particular journey, if you see, Linus Torvalds, he created the Linux kernel. Now, kernel is something which is the core of an operating system. So Linux kernel was created by Linus Torvalds and it was August 25, 1991. That time this announcement was being made. Initially just a hobby project, later it became a missing piece of GNU system. Okay, so I think it should be the masterpiece. Okay, so it became one of the masterpiece for the GNU system. Now, growth and adoption. So after 1991, if you see, from 1992 to 2000, combined with GNU tools to make a full operating system, so it became GNU Linux. Okay, so that is how, what is the relation between GNU and Linux or Linux, we can understand. And then once they started to develop and produce more products, then they were able to gain traction in several environments. And the main purpose is the stability. If a system is stable, everyone prefers to have it, even if it is a little difficult to understand and manage than other systems. Now in the modern era, after 2000 to present, so used in everything from supercomputers and smartphones, everywhere Linux is being used. It powers most of the internet infrastructure, cloud platform, and IoT devices. So now for today, if you see and discuss and think, what is there? The Linux is being used in everywhere. Even Android, if you see, it has got a Linux kernel. Okay, it's not having Windows, it's have Linux kernel. So everywhere Linux is there. Here are the Key milestones, if you see, like from 1991 it started. Linus Torvalds releases Linus 0.1. Then 1992 Linus is relicensed under GPL, General Public License. And 1993, if you see, first major distros here they came up in 1993. So Slackware and Debian came up that time. And then 2000, IBM invests $1 billion in Linux. And then 2004, Ubuntu releases beginner-friendly distros. And uh, and then 2007, Android based on Linux, that development began. And then Linux domains 2010 plus, if you see, so Linux dominates the cloud. So everywhere in cloud, if you see, like whether you go to Amazon, Azure, everywhere, so the kind of instance they will recommend, the first recommend would be of some Linux. Okay, whether it is DevOps, containers, everywhere you will be able to see Linux is there. Now, what are the features? If we talk about the features, then multitasking. So run multiple processes at once. This is indeed very much required in all the operating systems. Multi-user, many users can be created and all of them will be handling their data and other stuff independently. Then after that, portability is there. So runs on many hardware types. It doesn't give much of the kind of tantrums it doesn't give. So many places if you see, it'll be able to work. Security is file permission. So file permissions, user roles, and and firewall support. So this comes under security part, and networking is another feature because in the age of internet, we need networking and data to be transferred from one place to the other place. Now, different types of Linux distributions, if you see, so we have multiple Linux distributions. Like, what is a distro? First, understand. So, distro is a complete operating system built around the Linux kernel, and it includes some additional tools as well. Okay, and can be applications, package managers, tools, all that we can give. Now, major categories. So Debian based is one category, Red Hat based is another category, Arc based is another category, SUSE based is another category. So let us see from the Red Hat one. And before that, we have Debian. So Debian, like Ubuntu is there, Debian is there, Linux Mint is there. So all of them are Debian based. Debian is known for its stability and large software repositories. So that is the benefit we are getting, that it has got more stability, and it has got software repositories. Now, what exactly is a software repository? Like if you want to make use of some, let's say, editor, and you want it specifically to identify which language you are writing or typing, so that becomes a software package, and you can download such kind of a software package. Like we have VI by default normally, but you can download VIM. So VIM is far more better than VI because it is able to bring up colors, and that brings us more, I'll say, user friendly. When we are writing some keyword, it will come up with a color. So our work become more efficient. So this was just one example, very similar way. If you see, there are multiple such software repositories which help us to make our task, make our work easy. That is the purpose of what here it is written. It has got a large software repository. Now, second category, if you see, it is Red Hat based. Now, known for enterprise support, robust performance, so rough and tough kind of thing. Okay. So Red Hat based are basically used by industries at multiple places. Here we have RHEL, that is Red Hat Enterprise Linux, that is RHEL, which is a commercial. So for which you need to basically pay for licenses. Then we have CentOS. CentOS is now replaced by Alma Linux, Rocky Linux, because the CentOS last release has been stopped in the previous month. Now, next is Fedora. So Fedora is being very much used, like Ubuntu is one particular operating system which is being used. And second, if you see, even Fedora is being widely used in many educational institutions. And for research purpose also, Fedora is being used. It's again a community version. Then we have Oracle Linux as well. So like Red Hat, we have one Oracle Linux. It's coming from Oracle. More or less, the function of all of them are similar. Like it's not like one is doing some very specific task and another one is doing some another specific task. No, moreover, their functions are same. They can do similar works. Then we have Arc based. So they are focused on simplicity and user control. That's the main purpose, like why Arc based basically came. And here, if you see, we have Arc Linux, we have Manjaro. So they are examples. Now SUSE is there. So OpenSUSE or SUSE, they are again used in enterprise environments like Red Hat, or like we discussed here about the uh, let's say Oracle. Oracle is not so much used widely, but Red Hat is being used. Okay, so SUSE is also being very popularly used. We have SUSE Linux Enterprise Service. Now, some other specialized, if you see, we have Kali Linux, we have Raspberry Pi, we have the Tails. So these are some others along with Alpine Linux. Now, the motivation from here we should get is we should try to set up these particular Linux operating systems into our desktop, into our machine. So how that can be done is, I'll tell you one traditional way. Like VMware has been helping us a lot to install more than one operating system in the same system. So I'll be basically trying to start with some VMware workstation, and then followed by, yeah, and then what we can do is we can go for the setup using VMware and try to understand more on it. So here, if I show you, we have VMware Workstation Pro already installed with us. If you are not able to, find it, you need to install it. Now, the thing is, it has been purchased by some other company, and therefore you may not find the downloadables there. So you need to search a little more in order to download the exact VM what they are actually proposing. Okay. So now let me go to File and let me go to New Virtual Machine and create one virtual machine. So I'll click Typical, and after that I'll just select, yeah. So here I have selected Ubuntu image. You can see browse and you can select also. So it is somewhere, I don't know why. And now I need to search for it, the images. So I have selected Ubuntu and open. And that's why Ubuntu is visible over here. Now next, you need to give name. So let me give name here as INDEED INSPIRING inspiring, username INDEED, password be INDEED. Now password also have kept same INDEED. Yeah, I have tried to keep the password also same. So let me click on next. Name it as INDEED indeed, INSPIRING inspiring, and next. 20 GB is enough for this particular virtual machine. I'll click next and I'll click finish. So now what will happen? It will create a machine or a CPU. We had discussed that CPU has got certain components like number of processors. So this is a virtual CPU which we are creating. If I go to settings and yeah, so if we go to settings, if you see here, it has got 4 GB of RAM. It has got network adapter. Yeah, here you can see it has got 4 GB of RAM, two processors, hard disk 20 GB. Okay, this is what it has got here. And now if you see that the other properties also, if we want, we can, update and change. That's very much possible. The installation you can see is going on over here. And this installation we are doing with the help of VMware Workstation, and we are installing Ubuntu 24.04. This is the version which we are installing. It really takes good time to set up and install. So I would like to go ahead with a couple of steps which can quickly turn up. So you can see that the screen is completely black, and now something seems to turn up over here. Now this is the traditional way where VMware Workstation utilizes the virtualization technology. The laptops, they are enabled or they come up with virtualization technology, but this is normally disabled. And now what happens? It is enabled, and that's why, yes. So that's the reason why we are able to see that on Windows operating system, I'm able to install the Ubuntu operating system as well. You can see now, yeah, music it gave, and English we have selected. Now next, English US, okay, next, use wired connection, next, and skip it. Install Ubuntu, next, interactive installation, next, default selection, next, install third party. I'm not doing it now, just to save time. I'm not doing it now. Next, and you can do all that little later also. So erase the disk and install Ubuntu. Yes, next. Your name, I'll write INDEEDINSPIRING, inspiring. And password I'll keep Indeed, INDEED, Indeed. And here also INDEED, Indeed. And show password, Indeed. Now next. Now the timeline is perfectly selected. The basic properties are okay, and install. So now you can see that it has started to copy the files. So once again, let us try to understand. We need VMware Workstation to be installed. We need an ISO file of Ubuntu. That is another thing which is required. And then we can start this particular process of installing and setup. I have used Ubuntu as of now. What you can do is you can make use of CentOS, Red Hat. Okay, any which one do you like? You can basically, or which one do you need to use? You can use that operating system. Here, while installing, it is showing some of the work it has been done. So all the applications you need, install, manage, update all your apps. Now develop with the best of open source. So as Ubuntu is open source, many people prefer it to use it for development, use it for data analytics, data science, AI, ML, and it has been well managed from so many years. Even in production, also Ubuntu is being used. So that's another reason why we can go for Ubuntu. Enhance your creativity. So it basically gives the option for creating the, I'll say, a lot of softwares you can find which can help you to create different types of maybe cartoons or characters and 3D views of some models. So all that you'll be able to do. Gaming is something which everyone is much interested into. So it supports gaming as well. As per my experience, like there's nothing like Windows as of now for gaming and other creative things, and like which is most commonly used. And secondly, if you go for other brands like Apple, yes, so nothing like that. You can see below that it has also started installing the system and also keep on telling us that what all you will be getting. So private and secure. So Ubuntu provides all the tools you need to stay private and secure online. So that's the benefit of using Ubuntu. Whenever we discuss about why Linux, why not Windows, so it basically gives more security. That's the primary reason. Now, power up your productivity. That's another thing that 66% of the developers they prefer Ubuntu. So at our place also we have seen that for many cases Ubuntu is being prepared. Okay, it was set up but it was not used. Okay, so access for everyone. That's another thing because it's open source and anyone and everyone can basically quickly download it and start using it. That's another thing that everyone can get access. Now, normally this takes a couple of minutes. It also depends that how much RAM have you allocated, how much processors, how many processors have you allocated. So it depends on that as well. Okay, that's also one of the reasons. Now, help and support. So the official Ubuntu documentation isn't available. So you can see here that we do not have this particular mechanism. So what we can do is it is available on this particular link. So we can go to the link, open up, and then we can search for it. But as of now, the OS is yet to install. So if I click on the link, it will not get opened up readily. Okay, fine. Now, many a times what happens, like meanwhile it is getting installed, let us have some quiz and queries here. Let me ask you, and you can keep on answering them in the chat, the comment section. The first question is, what is an operating system? The second question is, what is Linux? The third question is, what is the difference between Linux and Unix? So meanwhile, I have been asking you the questions. You can answer them in the chat. Here you can see that it has been installed successfully, and you can see that the documentation has got opened after the installation is done. Some proxy things are there. So as of now, I'll minimize. Yes. So you can see that has got opened up, but installation is still running. Okay, that's good. Okay, so whatever links we want to basically click, so that means the browser has got installed, and that's why it is able to open it up. Okay, that's again interesting. Whatever is installed, it is able to. So your tracker setting, we are using cookies, and okay, except it's a hmm, nice. Okay, fine. Now here it says there is no enough space. Oh, that's another challenge. Okay, so you need to basically keep enough space whenever you are installing and trying. That's another challenge. So what I will do is I'll quickly try to make some space over here. Okay, so for that, let me open maybe downloads folder. I can have a couple of things. Uh, yeah, this is another challenge normally we always face of space. So with size, okay, okay. So I'm just making some space open and let me go back, retry, fine. And now let me check. it is still installing. So this happens sometimes. Once it will get installed, this is a desktop release. So sometimes we get only shell based, which is not a desktop based release. And this is a desktop based, so it will be easy for us to interact with the operating system. And another thing you can see over here is like as soon as we started to interact, so here we have chat basically thing available. Yeah, uh, so here you can see like you can fill in your details and fill it, send it to them if you have some queries. As of now, I don't have any queries, so I'll be just skipping this particular part. Other things you can probably read, and I'm just waiting for this to complete. Let's go for the logs here. If you see, whatever is happening, it shows all those things here. Now, another important thing about if we have opened up the logs is that we should be able to read the logs, understand from the logs, and uh, build a sound understanding of interpreting the logs. That's again a very important and crucial part in Linux. So you can see that different types of logs are being generated, preparing to unpack and all. Okay, some more logs. So running command, update init ramfs, generating slash boot slash init rd. So here you can see that the logs will keep on getting generated. And I'm just afraid a little bit that by any chance, if the space is going to get consumed again, then it is going to stuck this particular process in between. The interesting thing is if you are reading these logs, then you are able to understand the step-by-step internal or background process that how and what is getting installed step by step by Ubuntu. Okay, that gives an understanding. And who is designing this particular OS? They are also basically having a process, some steps to be followed. So this helps them even to follow the process in this particular case. Now the installation part is over, and after installation, the setting up the system part is going on. And I think it should also take a minute's time, and then we should be able to log in and should be able to see. So in my case, I have kept the password as Indeed, and I always recommend to keep the password as simple as possible. That's very much important, because if you forget the password, it will be really difficult and troubleshooting thing for you to, go back and check on it. All right, so meanwhile, let us have some more logs to be read. So let's read them. Meanwhile, the system is getting set up. So here you can see it's running some commands. So mount, bind, sys. You can see target sys with allowed return codes. So some value which basically is getting returned probably from there. So you need to basically read the logs like Ubuntu sub equity log, running command, and okay, so unattended updates. Fine. So let it happen. Okay, let it happen. And what we can do is now, once it will be done, then probably in the next session, I can show you up that how it gets started, how to log in. Okay, so this takes some time if the RAM is also low. So that's it for today. The final note is you can have VMware Workstation, you can have ISO of Ubuntu, and the ISO you can find from, you know, from here, Ubuntu ISO download. So from here, you will be able to find the ISOs. It gives the latest one also, and it gives the old releases also. So you can download it from here and it will help you. Okay, so I think everything is clear now, and we are good to close here with, we'll be waiting for this particular setup to complete so that in the next session, we'll be able to work on this particular platform. All right, thanks for watching, everyone. And I hope the kind of journey you are starting with Ubuntu, it will be a happy journey, smooth journey, and easy journey. And thanks a lot once again.